Hey everyone. For anywhere on Firebase where you feel you want a server for your serverless environment, Cloud Functions would be the way to do that. They're just snippets of code that you upload to Firebase, they run, and then they return a value back to the caller. Here are some use cases where I feel as though you have to use Cloud Functions as opposed to allowing something on the client. One is anything administrative. So for example, backing up the database or sending an email to yourself with metrics or to your users with a daily digest, let's say. Anything involving secrets, you don't want authentication information or payment information to be on the client, so you would do that through Cloud Functions. And then any computationally expensive tasks, you technically could do this on the client, but Cloud Functions can run for up to 9 minutes. So let's say you were doing something like video encoding and users are typically on their phones, you probably want to offload that to Cloud Functions. There are 4 major ways of calling functions. One category of this is directly, the other is indirectly, but of the ways that you can directly call a function, one is with HTTPS callable functions. These are essentially just like if you had made the function yourself and it was asynchronous and you were calling it there. So let's look at the definition of a function here. I've got the sum function and we say that it's the HTTPS callable function type. And here what we're doing is we're taking in the user's data, we're summing it and we're returning the total. So that's the definition. The call of it, there is one line to get the function's URL and everything else that Firebase is going to pack into the request for you. But then the call looks just like another call. We have await sum function, we pass in our operands and we get the total back. The next type of directly callable function is an HTTP function. And these are very similar to making REST APIs. So you see the typical rec res that is here for the request and the response. We take the operands out of the body of that request. We send back success and the total. Looks just like a REST API that you might call. And in fact, it's callable the same way. So if you wanted to only allow this for, let's say, get methods, you could, and then you could just hit this URL and specify, you'd have to change this code to use query instead of body, but you could specify your operands directly there. This is using Express underneath, so you can also use any Express compliant middleware. There are also scheduled functions. These are just functions that run at a particular time. So for example, every day you send out an email to your users. Finally, there's indirectly calling functions. And for this, you have triggers. There are a lot of different kinds of triggers here. So this might be something like every time a user creates their account, you might want to send them an extra email. Or maybe with analytics, maybe when a user makes a purchase, you trigger a Google Analytics event, and then it will send that user a coupon. There are some limitations to Cloud Functions, and they're not too significant, but I want to point them out anyway. One is runtime limitations. You do have quotas and limits that you can hit, and then at that point you need to contact support to raise. I will say this though, almost all of these I think are in the category of if you actually hit them, you're paying so much money that you probably shouldn't be using Firebase. For example, you're allowed 100 million invocations per 100 seconds. If you hit that, from just invocations alone, you're paying $25 per minute. So chances are you'll probably want to switch away from Firebase at that point. Egress traffic is any traffic leaving your function to a server that is not Google's server. So for example, let's say you're doing any sort of OAuth process and you need to reach out to Twitch or Discord or some other site. That's egress traffic. This is not possible on the free tier. It's not expensive, it's something like 12 cents per gigabyte, but you need to upgrade your project to the paid plan in order for this to even function. Otherwise, it will just fail with an error. Finally, you have to write your functions in Node.js. You can't pick another backend, but you can choose between JavaScript and TypeScript. If you've used Node.js before, then you know that environment variables are typically pulled from process.env. You don't actually have that same capability, but there is still a way to configure on Firebase how your functions run. That's different from production, whether you're running locally too. In production, you're going to use the Firebase tools to just call set on a key and give it a value. Pretty straightforward. And when you're running in the emulator, you're going to need a specifically pathed file, runtime config.json in the functions folder that has that same configuration that you've set up. So it's still easy to do, just different ways of doing it. Shifting gears here, let's talk about cold starts. We can see on this graph there are some function invocations that I have that are taking close to 8 seconds to run. But we can also see that this function should really only take about 29 milliseconds to run. What's causing this is a cold start. Firebase is doing a lot for you under the hood for almost all of its services, and functions are no different from that. Google isn't going to keep 100 servers at the ready for your function that might only get hit once or twice. Instead, they allocate resources when your function gets hit, and then your function needs to go through its own initialization that it might have done. So these cold starts will happen, and we need to figure out how to mitigate them. The first mitigation that we'll talk about here is optimizing your code. And this largely comes down to lazy initialization. In Node.js, you can define things in the global scope, and on Firebase, the global scope can be reused in between invocations. So if you declare something at the top of your code, but don't actually initialize it until you use it, that'll be perfect because you'll have lazily initialized, so it won't incur that cost if it doesn't need it. And then when it does need it, it could potentially reuse it. The other, and this should go without saying for pretty much any code on any platform, but you'll want to prevent crashes. I believe this will deprovision your instance, which will incur another cold start the next time it runs. You could keep your own functions warm by calling into them every so often, but the problem with this is that Google is not specific about when functions will get deprovisioned on their underlying instances. So you might have to call into this once per function every hour. It might be once per function every half hour. They could change that in the future. Finally, you could just use a different solution here. Let's say you knew that there was a function that was going to get called 5 times per day. You might not want users to experience that cold start, but then Cloud Functions may not be the best solution. You might just want a VM that's going to always be online, and we'll just handle those calls. Next up is logging. I think the biggest takeaway here is just to use logs. There's not too much to say here. There's an interface that you can use for searching through them. You can filter by the type of the log. You can use command line tools for them. You do end up paying for logs. You get, I believe, 50 gigabytes for free, and then you start paying per gigabyte after that. But in general, this data is there, and it's very helpful for you to be able to see what happened in a function after it ran. So go ahead and use them. One thing you might see in those logs is this particular error. And this looks scary at first because you see has been blocked by cores, and this might give you flashbacks to your front-end development days. This is not really a cores problem though. It all depends on what you're doing. It certainly could be a cores problem. But I ran into this 3 separate times, and I'll show you one such time. The other 2 are in my notes if you want to go take a look at those. I had a function that I defined at createAccount.js, and all of this code was perfect. This was totally fine. And then I was exporting it here from index.js so that it would be usable at the createAccount function. Now, if you remember Node.js requires, not necessarily import and export, you might already see the problem here. What I forgot to do is use .default. So I wasn't exporting anything, this function didn't exist, and that's what led to me getting this error that I saw here. So this I wanted to bring up because you might hit this and you might start searching for the wrong thing, but this typically just means you made an error somewhere in your function. Whenever you do run into such an error, you can always debug the functions very easily. If you're used to Node.js, then you've seen inspect and inspect break. You have the inspect functions flag that you can add on to the emulator command. So here we just call Firebase emulator start, and we pass in that tag. And then you can use any debugger that you want. I tend to use Chrome, so what I do is I open Chrome, I press F12, and then I click that little node gem, and that's it. Now I'm able to debug. And that's it for this video. There's not really too much to demo with functions because the bodies of them are almost always going to be your business logic. And you saw what it was like to define a function, to call into it. Beyond that, you can look at the documentation, but there's really not too much more from a user perspective. Of course, from an infrastructure perspective, Firebase is doing a lot for you, from scaling up, managing availability of these. I think it's an easy feature to use. Hope you learned something watching this video. Thank you very much.